So, as you've seen and we discussed over the day, so these early mechanisms of centralized justice were completely financialized in the sense of the use of incentives. And they were basically inspired by how blockchains were built, this idea of anonymous, permissionless architectures where anyone can get in. You don't need to prove who you are. Nobody cares. You just get the token and you are in, right? So this is how Leros was built in the early days. So anyone could be an arbitrator. They could be anonymous. I mean, if you don't know who the person is, I mean, how do you know one of the parties is not also one of the arbitrators resolving its own case? And also something that Sophie mentioned before, like, what do you mean that arbitrators having an interest, a financial interest in how the dispute, is resolved? This is very not common to the world of dispute resolution. The reason why these systems were built in this way is that since you didn't know who was behind an Ethereum address, in the end, you didn't know if there was not one guy just controlling many addresses. So the only way to prevent this civil attack was through having people stake economic tokens that have an economic value in order to be drawn, right? So this is what enabled us to make the incentives work. This was criticized by different people. We've seen this today. For example, Nathan Schneider wrote this very well-known paper about crypto economics as a limitation on governance. So this was answered by Vitalik, also mentioned, and part of the discussion was about how this worked in Kleros exactly. And then William answered that. So it was a very interesting discussion about the role of how economic incentives work and how they interact with our understanding of how this system should work, okay? And this lack of juror identity conflicts with how we think that justice should work. I mean, in the sense first that people ask, okay, but the fact that you have more money and more tokens should not give you more votes in a dispute. I mean, that's not cool. And the other big question we always got, what do you mean that some anonymous guys from the internet will solve my disputes? People wanted, vetted jurors. So remember, we always have this framework to think about adoption of this type of models. And the problem is that this didn't seem very ethical by many of the potential users of the system. And this was a problem, right? And then, we had the proof-of-personhood protocols, and this was the first time that we could start having on-chain identity for humans. And so now you can verify who is behind an Ethereum address and make sure that one person only has control of one address in the system. We ourselves launched a project called Proof of Humanity that was one way of verifying users. There are also others, and this works like this. So you have Alice that wants to have her address verified in this list of humans. She makes a submission with a deposit, and the submission into this list, and the submission. You had to send a photo of you and an address you wanted to have verified. And then you had to send a little video where you say that you were a human and that you were not already registered in the registry. So this is, of course, Vitalik submission. Well, there's the video. It's not playing. Let me see. Okay. So Vitalik, he should be saying, I'm certified I'm a real human and I'm not already registered in this registry, showing his address. So this is submitted, and then the submitter needs to get a vouch by someone who is already in the registry. So now Bob certifies that actually Alice is a human because he knows her, maybe. And then there is a period during which anyone can challenge this submission in case they think it's not compliant. It could be maybe not compliant because it is duplicate, or because it's maybe a deep fake, or not a human person. So after this period ends, so the profile gets verified and the user gets the deposit back. What happens if Alice now makes another submission to the registry? So she makes the deposit, the submission, gets the vouch, but some user says, okay, but this user was already registered, and then they can challenge her submission, and there is going to be like a trial made at Kleros, where the jury is going to decide whether this submission is actually a duplicate or not. Okay? And so if the jury rejects the submission, so the challenger gets the reward, the deposit of the submitter, and that keeps the list clean, let's say. So this is one method of giving one address to one human. There are others. One of the other methods is, well, based on more on biometrical devices like hardware like this orb and WorldCoin. And there are others that are more based on traditional ID systems. So you have your ID, your passport or your national ID, and then you can use that as your on-chain identity. Buenos Aires government is having like a method of a pilot of doing this for giving every citizen of Buenos Aires an ID on the blockchain, okay? And Vitalik, in this very good article, compares the pros and cons of different methods. I think in the future, they're going to be different. Some of them proof of humanity, like social verification systems, others with hardware like WorldCoin, and others like traditional ID systems, okay? So why this is interesting in the context of decentralized justice? Because now we can enable one person, one vote courts where some people will see this as more fair and more looking like what we understand as traditional dispute resolution systems. This was not possible before. And this also enables the possibility of more sophisticated methods of selection, in particular, based on this excellent paper written by Glenn Weil, Puja, who is here with us, and Vitalik, about a new type of token that is non-transferable called soul-bound tokens. I'm not going to go into lots of detail because Puja is the expert here, but this token, you can use it to certify that some user or some address has some certification of like some diploma, some skills basically, and the university could issue a soul-bound token for any user that passed some test. Or you could have this soul-bound token certifying that you belong to some community, like you're a citizen of like the city of London, right? So now you have that. So, and then you can start making courts where only people who have passed this exam or this verification because they have some skill to be selected, and not anyone can be selected, but only people who have proven their expertise. And also you could have only, let's say the city of London was to use Kleros for solving disputes, I know, parking tickets. So, and they only want citizens of London to be selected as jurors. So now this is possible with this type of tools. So you could give a soul-bound token to citizens of London, and then now they can vote and courts cases in Kleros. Okay. So what this gives us is a more flexible and maybe more legitimate, space for mechanism design, because now we have more tools that we can use that we didn't have when we started. And the question is how we can start using this for making systems that are secure and also like seen as more legitimate by the users. Okay. So thank you very much. And yeah, who continues? Yeah. Okay. Thank you. Okay.
Yes, that's right. Okay, so I've talked a lot today, so I'll try to be brief. But just to expand on this discussion of soul-bound tokens and like identity mechanisms in decentralized justice. So I talked back in my intro presentation, in the morning, about these different security models as you try to like bring in different identity tools. And I said the like Kleros 1.0 security model is basically assumes that no participant, including group of participants, can get half the votes, half the tokens, and as long as they don't get like more than half of the pool of stake, then they shouldn't be able to get like more than half of the votes if you take a big enough panel, law of large numbers, yada yada. And then I said, okay, with like proof of humanity, proof of personhood, you can come up with this like layered resistance model, where now the idea is that you should your security model is that you either need proof of personhood to be secure, or that the attacker can't get too much large percentage of the stake. It's not quite half anymore, but it's pretty close. And then you've layered these like two kind of like types of attack resistance against 51% attacks, people taking over the court together. And now, like, thinking about cell-bound tokens, I'm inspired by a lot of work that Glenn Weil has done along with Puja and Vitalik, and also there's a follow-up paper with, I think the co-authors were Glenn Weil again, Joe Miller and Leon Erickson, that looks at using cell-bound tokens to weight in governance generally, but specifically to weight contributions to a mechanism that is called quadratic funding. So I'll just briefly mention that to sort of like highlight the parallels for how I think. I'm very inspired by this. The idea here is that you want some kind of like subsidy mechanism, that people contribute some amounts, C1P, blah, 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 CKP, your users 1 to K, to some project. And then they receive a grant that is this like scary formula in the bottom with the square roots. And the idea here is that if you have contributions from lots of different participants, you get a bigger subsidy. So this is the way the formula works. If you have like a big contribution from one person, that's not so useful. Like because of this like square root squaring effect, just because of the way the square root function grows, it's like what you want is to have like lots of small contributions, lots of terms where you're adding lots of square roots together, and that gets a much larger subsidy. So here, like, and we had this contribution of 7 in both cases. Left, there's a substantial subsidy. Right, 0 subsidy. And they have this interesting geometrical representation of this, where you have this like square with the like blue diagonal down the middle, which represents people's actual contributions, and then the white part is the subsidy the mechanism is giving to some public good or some project. Everybody's putting in their small amount, and then the broader mechanism like gives like this kind of like matching funds, or like more potentially than matching funds. And then the like game, if you're an attacker, because again, I'm paranoid and I think about attack resistance all the time, is how do I manipulate the square? How do I get extra subsidy by trying to like mess with my contribution somehow to try to exaggerate the white portion of the square? And how like my ability to do that depends on my ability to like hack identity mechanisms that as we'll see in a second. So then if you have SBTs, which are supposed to be this reflection of your belonging to some kind of community, maybe I have my online diploma from some school like that I'm a blockchain developer. Maybe I went to a conference and I have some kind of attendee SBT. Like ultimately that gives some, breaks my participants into groups. I have, people with different backgrounds, ideally like diverse problem solvers. There's a lot of social choice research, like a lot of social science research that having diverse people like can have better decision making in panels, even if they're each not like as high performing as the highest performer. If you have like a diverse group of moderately good performing people, like that can be better sometimes than like a monolithic block of people that maybe have a slight average advantage on average. And then if I have like a bunch of different soulbound tokens I'm trying to like weight together, we use formulas similar to what people were using for quadratic funding to try to give you more or less odds of being drawn in the case. So imagine that people have maybe the second slide, but whatever. So I guess so imagine that like the guy in the green shirt has contributed 7. He's staked 7 tokens, and now he's in like 2 groups because he has 2 tokens, and basically his like contribution is like split in half between the 2 groups, but everybody else is only in 1 group, so their contribution is assigned to their group. And basically you can look at the stakes or the contributions that people make being like assigned to different groups as defined by people's soulbound tokens, and then you can like for quadratic funding you can like do a similar thing you did before, but now instead of putting people under a square root based on individuals, you put them together in groups. You can do the same thing for Claros, where my odds of being drawn depend on how much stake I have relative to the like square root of the total stake of all the people that share my soulbound token, using these like kind of scary formulas, but ultimately like with a lot of the same intuition as the sort of quadratic funding research had. And now, instead of the game being like an attacker wanting to exaggerate the white space that corresponds to a subsidy in the square, it's a question of can they make the kind of like dishonest part of the square bigger than the honest part of the square. This is what a 51% attack looks like now. Like you have all of the, just going back here briefly, like the square roots and this sort of like reweighting is resizing different pieces of my kind of decomposed square here that you then reassemble into like what the attacker's weight is versus like the honest parties. The mechanism is giving people some extra weight if they're kind of plural, as evidenced by like the white regions. And it's a matter of like making like the attack better or worse than the honest regions. So now there's a new, even more complicated security model that has to do around with like staking large portions of tokens and having the right coordinate combination of SPTs. A lot of interesting research questions here. I've been looking at, like, this almost gets to questions around AI and kind of like clustering algorithms where you're ultimately putting people into groups. You could use a clustering algorithm to do that. And like, you know, here, maybe I have redundant information in people's spellbound tokens that they reflect ultimately like, you know, like I have two tokens that basically tell me the same thing. If I ran this through a clustering algorithm, it would just filter out the sort of redundant information and put people into groups using, you know, whatever clustering algorithm you use. There's a lot of cool stuff, you know, that's like, you know, your favorite linear algebra-based clustering algorithm that ultimately puts people into clusters. And then what is the attacker's ability to manipulate that? What are the best attacks they can do to try to like break themselves off and form like what looks like an alternative cluster to the system? Do they like add extra soulbound tokens to their fake profiles? If they hacked a soulbound token, you can give like their soulbound token to themselves. Is that the best way to spend their resources? Maybe they give fake soulbound tokens to other people to try to make them look more similar than they actually are. And then like the attack model here is complex, but an interesting subject of research that kind of, you know, at the boundary between these kinds of decentralized justice ideas with, you know, like manipulation of clustering algorithms. So I will wrap up there, and we can move to Puja's talk.
Okay.